Hello, everyone. Joining today's session. It is on Decentralized Future. Mostly, I'm going to spend some time exploring blockchain, crypto, NFTs, and decentralized autonomous organizations. So, this is a very complex subject. At the same time, I would like to only demystify today. I don't think I can spend in detail about financial transactions. Today, the bank is the intermediary. Then, if you want to have some agreements or contracts, then you have the advocates. And you have the insurance companies in the middle to pay. We have the auditors in the middle to reconcile our accounts and all. Then you have the government. For example, if you want to register a land, then government play the role of intermediary to ensure that the land is valid and all. Okay, so what does it mean? So for most of the transactions, what we speak, these are very limited. You have some intermediaries and you have to pay considerable fee or considerable money for these trusted intermediaries. Okay, then can we avoid them or can we minimize the participation of these intermediaries? At the same time, can you complete the transactions without these middle people? All right. I think that is the most important area which we need to understand before we even speak about blockchain. So I don't want these intermediaries. Then they are the trusted partners. Without them, you are not sure whether the money is going the other side or not, whether the land what you are registering is right or wrong because somebody is validating. Now that validation or the trust element, if it is done by software, not by any institution or individual, right? And also that is done by some anonymous or of course known distributed participants. I will explain what does it mean. The first message is whether you can have the trust without institutions like banks or government agencies and all. Yes, but how? The trust is established with software code that is also called smart contract, which we'll talk about it. So the first fundamental shift here is I don't want the intermediaries like institutions, but I can do the same thing with software code. That is a major shift, the first fundamental thing we have to understand in the blockchain. So, how the trust is established? When I say that software will do the trust, it is not just simply software. There are so many elements will play a role when you don't want an intermediary and you want to get it done with the software code. There you have cryptography and distributed network ledger. I will talk about it. Then there is a collaborative consensus mechanism because you don't have any institution but somebody has to do that. Of course it might be a software code. Okay, and the final one is this is the core part of the trust element is a smart contract. Don't too much get into this, but the key message I would like to give here is instead of the intermediaries, if the trust is established with the combination of cryptography, distributed network shared ledger, collaborative consensus mechanism, and clever code, that is called the blockchain software based trust. All right, the first fundamental element if you want to use the blockchain is you have to have a wallet. Okay, that is like a digital wallet. Okay, in that digital wallet you will have some identification in the form of your private key and public key. Then without wallet you cannot do the transactions in the blockchain. Okay, so this is another important element. The blockchain wallet is very very important. Now let us look at so how the trust is established. So let us say if you start a transaction, Usually, when you start a transaction, you sign it, right? When you want to deposit money, when you go to the bank, if you want to do physically at a bank, you usually sign it, right? That signature manually not required. That can be done by cryptography. That means the sender trigger a transaction, and then that transaction is encrypted using a mathematical algorithm, and then a private key is used to digitally sign it along with the mathematical algorithm. That there is no physical signature here. How the digital signature is done? Encryption and also a mathematical algorithm with private key combination. Okay, that is the way the transaction is signed. Then at the receiver side, the decryption will be done, and there is a public key, the corresponding to the private key this side, and mathematical algorithms will be there so that the transaction is validated and it is not tampered in the middle. Okay, because it is in an unreadable format. I don't think you need to really get into very details here. I'm trying to explain when the intermediaries are not there, cryptography is used to digitally sign a particular transaction with mathematical algorithms and private public key combinations is what the key message I would like to give here. Once the transactions are signed digitally, the same thing I already explained here. So there are mathematical algorithms like MD5 or SHA-256, then the hash function. Okay, this is what digitally signed transaction. So once the transaction is digitally signed, okay, typically if you have the banks or governments and all, if you look at left side, there is a central validation of those transactions using your software applications. They could be banking applications or ERP applications and all. Then the transactions validations are done through some business rules, but it is a central validation. Okay, is digital. It will be many nodes called computers. If you take a public blockchain like Bitcoin, then the financial transaction will be distributed to around 55,000 nodes distributed across the world. The 55,000 nodes means the powerful computers, which has a software code called the validation code called smart contract. So that this digitally signed transaction is now distributed. In case of Bitcoin, for example, maybe 50 plus thousand nodes, it is distributed. Every node computer, you have the smart contract. That means a clever code. That clever code do all the validations, whether this transaction is coming from the genuine source, and other important validation needs to be done, which anyhow you decide as per your business. Then at every node you also have a ledger. It is like a database, it is like a ledger. Okay, ledger is nothing but every transaction is entered in one two three. There is nothing like you can delete any transaction, you can only reverse it. Okay, so let us say if it is a Bitcoin, the transaction which is digitally signed is distributed to 50 plus thousand nodes. Then 51% of those nodes, that means maybe 26,000 approximately, when validated by the smart contract at that node, that means that when the code is run at that computers, the result must be same. That means the validation done by these 26,000 nodes, what the result, end result it is giving, must be same at least 51% of the nodes. Then because you don't have intermediary, right? So you look at the complexity here, it is not possible for anyone to bring that much of electricity and validation algorithms to ensure 26,000 computers you have to use and ensure to cheat it and all not possible. That's where the blockchain is very powerful. 51% of the nodes have to validate. Bitcoin, if you take Ethereum, probably it is 6,000 or 8,000 nodes will be there. It depends on the blockchain type, right? Now the transactions are now validated. 51% nodes are saying yes, this is a valid transaction. That is the step one is completed, validation. Okay. After this, what happens is When these transactions are validated, 51%, for example, I am talking only Bitcoin, okay, then they are all at nodes. Once it is validated, it is then a very genuine transaction. All 56,000, 50 plus thousand nodes of that blockchain will have this valid transaction. At every node, you will have this. Like that, for every transaction you are completing, one, two, three, four, five, six, seven, eight, nine, so many transactions happen in a business, right? All transactions will come, you will publish it to 50 plus thousand nodes, and 51% nodes will say it is valid. All valid transactions are available at 50 plus thousand nodes and all. Now, what happens is you group these transactions at every node into a block, right? So usually in the blockchain, 2000 transactions are grouped, that is called block. If you take Ethereum, the block size might be different. Now what happens is, if you take, for example, 2000 transactions in a particular block, now the block is created at every node within the blockchain. Now this block is nothing but all these 2000 transactions will have some value. Okay, I don't want to complicate this. That is called, every transaction will have a mathematical value called hash. So all the 2000 transactions hashes are combined, and there will be one hash created at the block level. Okay, now every block will have hash of its own, timestamp, and also the hash of its previous block. That means the block 10, block 11, block 12, all are now linked like a chain. You look at here, block 11, you will have the block 10 hash. If you look at block 12, you will have the hash of the block 11. How these hashes are created, look at here, transaction 0, 1, 2, 3. Every transaction has a hash value, then they are all consolidated 0, 1, 23, and finally you will get one hash value. Okay, so now this is called a blockchain. But the very interesting thing here is, now again, every node where these blocks are formed, every block will be again validated. Like each transaction is validated at the node, each block is validated now for its correctness and all. All the 2000 transactions within that block are validated. If anybody in case hacks it and tamper it, then automatically whatever a validation algorithm is run, again it is a smart contract as nodes, it fails. So if it fails at any of the nodes, then the transaction is invalid. It has to be getting the same value of validation from all the nodes where the blocks are there. I mean, this is the concept. What I am telling here is in a very simpler language, but not really that easy. Okay, to summarize, why this much of complexity they created. The transaction is coming, you digitally signed, then you have 51% of the nodes have to validate, then all these valid transactions are coming and sitting at the nodes, then you are grouping them into blocks, then each block now is related with hash values and all. Now again you are validating the block and all, because you don't have intermediaries. The cryptography, the mathematical algorithms, and the smart contracts are taking the role of the intermediary and creating all the roadblocks for the hackers and others to avoid tampering the transactions. That's where the stringent validations are being done. So that is called blockchain, because it is a chain of blocks, right, at each node, and you can't break that chain that easily. Okay, this is what conceptual. Okay, that's, I think I will just summarize this blockchain and all. Now, the other important fundamentals I would like to give here is the key terminology in the blockchain, especially in the crypto area, are coins, tokens, and currencies. Okay, if you look at some of the blockchains like Bitcoin, Ethereum, Polygon, they're all already available blockchain platforms available. When these blockchain platform providers give the native currencies or assets, that is called usually coin. It is a currency basically. If you take Bitcoin blockchain, it is a Bitcoin. If it is Ethereum blockchain, it is ETH is a coin actually. Okay, so like that, if it is given by the platform provider, it is usually called a coin. And if you create your own using these platforms, then it is called token. Okay, so that's where the digital assets built on the top of the existing blockchain network. And sometimes what happens is, if you look at bitcoins or all these are very volatile. Sometimes it is $60,000, sometimes it is low and all. So to avoid that, they introduced some other name called currency, that is a stable coin. That means if Bitcoin, one Bitcoin is equal to some a fiat currency value. Okay. Example I'm saying here, Tether is a cryptocurrency, USDT. One Tether is equal to one US dollars. They fix it so that the value, even it goes up and down of the cryptocurrency, this whatever you first linked, that tether, one tether is equal to one USD, that is fixed. It will not be dependent on the volatility. Anyhow, this is very simple, I think, definitions. Coins which are native come from the platform provider like Bitcoin or Ethereum, others. Then tokens, you create your own currencies or coins, then they are called tokens. And stable coins are basically the ones to take care of the volatility. These are all the currencies available in the market today: Bitcoin, ETH, then Binance, Solana, Cardano. I mean, all these things are there. Some examples how even there are so many regulatory limitations are there in different countries, but slowly in few countries the cryptocurrencies are also used in the businesses in the place of the fiat currencies, like rupee, Indian rupees or US dollars and something. They are all called fiat currency. In the place of fiat currency, today in some of the countries they are allowing to have cryptocurrencies also. How you can change the cryptocurrencies to fiat currencies? There are some cryptocurrency exchanges are there where your cryptocurrency can be changed to fiat currency, or fiat currency can be changed to cryptocurrency. That we are not talking now. So you can do very faster cross-border payments with the traditional way of banking and all. The transfer happens. Recently, somebody transferred. It took 3 4 days, but this can be done pretty faster when you transfer the cryptocurrency from sender to the receiver. Okay, that is one advantage. What, and at a very lower cost. Okay, that is one advantage of the cryptocurrencies are allowed if you want to transfer the money and all. But some countries have still a lot of regulations and limitations. Then the other beauty of micropayments is you can divide this cryptocurrency to the minute level. Okay, so that means if suppose you created a particular video and somebody see that video and they like it, they can pay a very fraction of the cryptocurrencies. That means micro payments, which in fiat currency they are fixed, right? You have dollars, you have cents, or you have rupee, paise and all. But in this case you can divide that so that you can pay to the extent of the level of micro payments, to whatever the level you want you can pay. Whether you created a content and somebody view it and they want to pay, they like it, they can pay. And machine to machine transaction, sometimes you are connecting one device with another device. When the transaction started, probably you have this sender device have to pay some cryptocurrency to the receiving device, of course as per the contracts and all. That is very easy with this cryptocurrencies. Okay, micro payments basically, which is practically very difficult with the, because there are fixed denominations are there. Then you can also have the customer payments. They have the, today some of the countries already allowing, you don't need to pay through your credit cards, debit cards, or physical fiat currency. You can do the transactions. If you purchase something, you can pay with cryptocurrencies, right? Okay, this will reduce the transaction fee. And most of the people who are tech savvy or crypto enthusiastic consumers are there, they love to use the payments through. Then some of the companies in some countries where it is legal, loyalty programs are introduced where if customer they purchase something, I purchase a book, then I get a token. If I purchase second book, I get a token, right? Like that, I can accumulate those tokens and finally I can get a value from those tokens, which is called reward. Okay, I think these are all very simple examples. The point what I'm discussing here is cryptocurrencies also can be used in businesses, but you have to check which country you are in and with which country you are doing the transactions, whether they are legally allowed, what regulatory challenges are there and all. And if there is no challenges, you can use them. Okay, so that is the message. All these cryptocurrencies work under blockchain. It could be Ethereum, or it could Bitcoin doesn't allow you to have your own type of currencies. Okay, I mean transactions, whatever you want. That's where Ethereum has come. Okay, Bitcoin, the smart contracts are fixed at each node. But in Ethereum, if you use, for example, you can write your own software code as a smart contract. You can introduce your own business rules at the nodes. Okay, this is what I think different platforms are available today in the blockchain: Bitcoin, Ethereum, Binance Coin, Cardano, Solana, Ripple, Hyperledger Fabric, which is enterprise scale, Coda, then IBM blockchain, so on and so forth. Okay, look at here one example I said. Now with this concept, with the blockchain, without any sub registrar, for example, within the governments, let's take in India, can you do land purchase? Yes, you can do today. We don't need any sub-registrar. Why sub-registrar required? Sub-registrar basically verify whether the land is legal and what is the provenance of that land, from where it has come, what is the link, documents, and all those things. Ideally, they have to verify and say this land transaction is the right transaction. If my smart contract is doing that at multiple nodes as I design, you may not have 50,000 nodes. It is defined by the government. How many nodes are required? What is the validation criteria? How the smart contract needs to be written with what validations and how many nodes, and what is the percentage of nodes needs to give validation? How the blocks to be created? All those designs have to be done by the government, and then land transactions can be done without any human being. That is sub-registrar here. Then election officer is not required. You have election officers and all. Some of the countries already started doing these elections for their internal board meetings and other shareholders voting and all. With blockchain, no intermediary election officer. You can do everything through blockchain. You can sit at home and then do the voting. Okay, this is what at a higher level the blockchain, the concept. I hope you understand. I tried to simplify and demystify. In summary, blockchain, you don't need intermediaries. Cryptography, smart contracts, mathematics, and all will help in ensuring or replacing that particular intermediary and doing those particular validations. Because you don't have the intermediary, you put so many nodes in the distributed model and put the smart contracts are a code, and you are putting a consensus mechanism of 51% nodes in some cases have to validate and say that the validation result coming in all these nodes is same, then that is a valid transaction. And again, there are some formulas, you block them, you create them as a blocks and then link them, and again you validate the block, and ensuring that at all the nodes the block validation is done. And this much complexity they introduced because intermediary are not there. The next concept I would like to introduce here is the Web 3.0. Okay, so web, if you look at Web 1.0, they're all static pages. 90s it started, right? We used to have website, there's nothing, only static page. Users just are the readers, no interaction. You can't do anything. That is 1990s and 2000. When it comes to 2000 plus, if you look at in the bottom Web 2.0, then users started generating the content. That means the social media has come, the interactions happened. It is not just only reading, you also started interacting. Okay, but there is only central database where you have Google, you have Facebook, you have Twitter type of companies have come. They started commercializing our data because they are centrally maintaining our data. It is not distributed or decentralized like in the blockchain what we mentioned, right? If I put a tweet, what happens? It will go and save in their servers. But if you move that to blockchain, for example, my tweet data will go and sit in multiple nodes, right? It's not like just one central, and that is owned by me, not by any company. So the Web 3.0, the most important thing is in the Web 1.0, it is just reading. Web 2.0, you are able to interact. Web 3.0, you are able to get into the system that is called immersive. How you get into the computer? That is through VR and AR. The virtual reality will come into a picture. You wear these headsets and you also wear the VR suit, then your avatar is in the computer, then you can do the here whatever you want, then your avatar which is in the system is doing. That is called immersive experience, which is one important feature of Web 3.0. Web 3.0 other important element is it is run on blockchain. That means your transactions or interactions what you do on the Web 3.0 applications, they are not stored in the central databases. They are decentralized nodes. Your data and everything will be stored in the ledger form. That is another important feature of the Web 3.0. The other interesting thing with Web 3.0 is it is semantic web. That means the data or content you are showing on the web is very structured. It may look unstructured. Okay, that is semantic web. You can do query and you can connect multiple websites, for example. The semantic web means, but you can write the like SQL queries. You can write the queries in such a way it can pull the data from multiple websites, and you can create your own content what is required, which otherwise is not possible. That is semantic web, right? So in summary, Web 3.0, the metaverse comes under Web 3.0 because you are giving immersive experience. Then all are decentralized applications. There is no central database, and you also have the decentralized browsers, and cloud storage is also decentralized. And also there is another interesting concept: non-fungible tokens also comes under this Web 3.0 era. Okay, this is metaverse. This is a competition to Twitter or a Facebook type, where you can also do exactly same as Twitter and Facebook, okay, Mastodon, where the but your data is not stored by Facebook or Twitter or Google type of companies at central. It is distributed across the multiple nodes, and the node owners are going to validate everything what you are doing. It is not monopoly by one, but the validations are done by thousands of the nodes distributed across the world. A lot of, I think, internal mechanisms will be there, how the consensus mechanism, who can really validate, who can vote, and all will be there. But the key message here is you are going out of the clutches of the big companies who are commercializing your data. Now it is your own data. You can even start commercializing your data because it is decentralized and stored in ledgers of the blockchain. Then this is a dbpedia. It's like a wikipedia, but it is a semantic web. As I mentioned, semantic web means it looks like unstructured data, like a content and text, but it's structured internally. It is framed like that, and you can really have the queries using some different technologies. In the bottom you look at rdf, owl, sparkql, and all. Then you can combine the data from multiple websites through these languages and all. You can query it and you can get it and all. That is semantic web. Okay, so the decentralized apps are there again. They are not like a typical your internet apps or web apps what you define. The underlying layer is not simple databases like your rdbms, oracle, or not only sql. These decentralized apps, when the transaction is completed, it is validated across multiple nodes, and the data is stored in the form of a ledger at multiple nodes, whatever I explained as a blockchain. So the decentralized apps are basically run on the platform of the blockchain. Okay, that's so. Now they also Web 3.0 also an integral part of this decentralized apps and all, right? I think that's what the Web 3.0. So it is immersive. It is having a semantic web, and it runs under the blockchain platform. Okay, that is the difference between Web 1, 2, and 3. Then the other interesting concept is most of the people today talking about non-fungible tokens, NFTs. What are they? So the NFCs are like very unique. That means you don't find. Okay, for example, if you take home, my home, but exactly same in the community, but both are different because my geographical locations are different, right? Okay, so my land location is different, so on and so forth. It is unique, right? It is distinct actually. Okay, so that basically again runs under the blockchain. So if you take a digital art, image, video, or a music, what you do is you digitally certify that the ownership of that particular art. So this digitally certified image is called NFT, non-fungible token. Okay, that means you cannot repeat the same thing again. You will not have that. It is very unique and special. If I created an image, okay, and then I digitally certified that, then that becomes an NFT. If I created a video and I digitally certify that, it is a NFT. Okay, now once this become an NFT, they will be available on the internet like OpenSea type of platforms. They are called the NFT marketplaces. So people create their images, videos, music, cards, even that their memories. For example, maybe I played a game in cricket long back and all. Okay, there might be a T-shirt, or there might be a bat, or there might be some photograph. All those are memories, right? So those memories also you can translate to NFT by digitally certifying it. And a real estate land, for example, is there. The real estate land details are taken. What is the size? What is the location, etc., etc. All the details of that land can be translated to a non-fungible token, NFT. Okay, okay. That's again. What is that? It is not a real physical real estate. Nowadays, some of the marketplaces are available. You will purchase the virtual real estate. Let us say at the Manhattan, I want to have my office space. Everything is imaginary and virtual. I will purchase a place, office space within the, let us say, metaverse, which is a very virtual world, right? And I create my office through 3D modeling or designs and all, and I assign an NFT to that. That means my office. So to why I'm creating that office? Okay, why? Because I wear a VR headset and VR suit, then automatically I get into an office which is in the 100th floor at New York. I am now got into an immersive experience of working at 100th floor of a big building at Manhattan, New York, is what I want to get that experience. That's where I am purchasing a virtual real estate. And when I want to work, I wear the VR headset and my avatar will get into the computer in the metaverse. And when I am working here with my goggles or whatever, gloves and VR suit and all, my avatar exactly, I get a feeling that I am in the 100th floor of that one. That is a virtual real estate. Okay. All right. I mean, there are so many things you can make non-fungible tokens, and I don't know why people really spend, which doesn't exist. After all, these are all digital. A video is digital, image is a digital, and a photograph of a T-shirt is a digital. Everything is digital, and why you spend too much of a money? Look at here an NFT artwork. People, I think that guy has done 13 years. He has created some images and something on the net, arts and all. He combined all those things, 13 years of work into one art, and it's digitally certified that and made it NFT, a non-fungible token. Can you imagine? $69 million people are spent to get that. That means that one thing. Nobody can again purchase. Huh? It is original because it is digitally certified by these people. Okay, that NFT artwork, which is the accumulation of, I think, 5,000 plus images or what, okay, of his own work, and he made one and he sold it as an NFT because it is digitally certified. $69 million. I asked myself why people are that crazy, because it is novelty and hype. Maybe the youngsters might be so much of interested on this, or fear of missing out. Okay, if this NFT 69 million you purchase, you can sell it probably for 80 million. That is the hope, like in any other stock market, right? So that is another business emerging. You purchase from somebody for some money and then you sell it off. That's where, oh, if I don't do that, probably I am fear of missing out. And the gambling, what I said, right? Speculation. And also sometimes it is a social status people are feeling. Oh, you know, one thing, the Amitabh Bachchan's video poetry, what he showed is digitally certified. It is the original Amitabh released video, and I have that. Is a social signaling or a status? Because of that reason, also people are purchasing. Even some of the movie stars, unfortunately, the hype was created, but today, I think I'm not sure whether really that hype is there or not. Kamal Hassan created some of the metaverse things, and people started purchasing some NFTs of his own photographs or something. Amitabh Bachchan tried. So many people. Okay. Now NFTs can be used in the digital art, creativity, gaming industry, and supply chain, media and entertainment, fashion and luxury goods, real estate, virtual land. We already discussed. Even legal documentation, you can digitally certify and make it as an NFT. Okay, contracts, for example, right? Okay, so I think this is what the concept of non-fungible tokens, and which is not easy. You can make any asset into non-fungible token with some format is available here. So that's what. So OpenSea is another marketplace for NFTs. It will have so many arts where you can purchase them in the form of NFTs. Then the ownership will be transferred to you from the seller. The digitally certified original digital art, for example, transferred to you. You are the owner now. Okay. Can you say that if somebody can recreate it? Yes, recreate it. But it is the original. It has come from the originator. That is the social status you want to maintain. But you might be having the similar arts in, I think, internet freely available. Okay. It is something like, as I mentioned, it is a craze, it is social status, and something uniqueness. Really, you don't get it otherwise. All right, next, my last part of my session today is when blockchain is introduced, I talk about how these decentralized nodes are available, intermediaries are not required. Then Web 3.0 has come under this platform, which is semantic web, where web is structured. Then you have the decentralized applications, so we can build it with the blockchain as a platform. And also you can get into immersive experiences, that is the second part. The third one I spoke about, the NFTs. The last part of my session today is the decentralized autonomous organizations. Imagine a situation I said when sub-registrar is not required. Imagine a situation I don't need any HR in my organization because all the policies, HR policies, all the agreements and everything is translated into software code called smart contract, put it into the nodes, and all the transactions, if you want to apply a leave, there is no need to get the approval from your boss. Automatically the smart contract will validate it among the multiple nodes. Yes, this is a valid transaction, you have the required number of leaves, I think you can go ahead and all. If the procurement you want to do, why you need a purchasing officer and all? The smart contract can do among the multiple nodes the validation. If it is within the threshold, yes, I think immediately release the thing. But the validation is not done at one node in the central location, right? It is done across the multiple nodes, right? Multiple nodes. So this is called, when you build an organization with blockchain as a platform, and when your transactions are validated by multiple nodes under the blockchain with the smart contracts, and then those transactions are grouped into blocks, and those blocks are again validated, and then your intermediaries within your organization also can be minimized. One example, as I said, HR manager, other could be supply chain manager, the other could be procurement manager. Those particular organizations are called decentralized autonomous organizations. The concept is evolving, but this decentralized autonomous organization concept in the finance has matured. My next session will be that. Exclusively we are going to speak, I am going to invite one of the youngsters as a guest. Decentralized exchanges, that is called DEX, and decentralized finance, okay, DeFi, which is different from centralized finance, okay, CFI. So that is a very important part of decentralized autonomous organizations. In addition to that decentralized finance, there are so many decentralized autonomous organization concepts are evolving in the manufacturing industry, and in the governance and intellectual property and food industry. Very simple message: if it is a decentralized autonomous organization, I don't want intermediaries. The role of intermediaries needs to be played by smart contracts, cryptography, blockchain nodes, validations, blocks, validations, and all. If you are able to build that organizations, automatically the human interventions will be minimized. Smart contracts becoming more and more prominent. Blockchain is becoming more and more prominent, but it is very difficult and complex. You cannot replace. It may take few more years if you want to build decentralized autonomous organizations. And in these decentralized autonomous organizations, you will have blockchain, you will have NFTs, you will have Web 3.0, you will have decentralized apps, all those things. That means a new set of technologies, a new mindset, new capabilities are required by the CEO organizations. Work with the businesses to ensure they build these decentralized autonomous organizations backbone. Okay, so this is what DeFi, which we are going to have in my next session. With this, I will conclude. Today, we spoke about the concepts about the blockchain, then Web 3.0, NFTs, decentralized autonomous organizations. We'll spend more time in our next session, decentralized finance, DeFi. Thank you so much.